Show that the function f of x equals tangent of x over the square root of 4 minus x squared is continuous at every point on its domain, and then find its domain. A function f is continuous on its domain if every function that is used to combine this function is continuous on its domain. And so this function f of x, we know that it is combined from tangent of x, and tangent of x is continuous on its domain. The square root of 4 minus x squared is also continuous on its domain. The domain of tangent of x is all real numbers except at odd multiple of pi over 2. That is plus or minus pi over 2, plus or minus 3 pi over 2, and so on. The domain of the square root of 4 minus x squared is all real numbers such that 4 minus x squared has to be greater than 0. Technically, it is greater than or equals to 0, but since the square root of 4 minus x squared is in the denominator, so we cannot make it equal to 0. To solve for this inequality, we would factor the difference of two squares. 2 squared minus x squared is 2 minus x times 2 plus x. The value that would make this expression 0 is negative 2 and 2. We can solve this algebraically too. It is clear to solve the inequality using the number line. Pick a number in its interval and check the sign. And so pick any number between negative infinity to negative 2, negative 3 for example. If we plugged it into 4 minus x squared, then 4 minus negative 3 squared is a negative number. Negative 3 squared is 9. 4 minus 9 is a negative number, so equality does not hold. And so we cannot use negative infinity to negative 2 in the domain of the square root of 4 minus x squared. We move on and pick another number in the next interval, 0 for example. 4 minus 0 squared is 4, which is positive, and so this interval will be in the domain of the square root of 4 minus x squared. And lastly, if we pick a number in the last interval, 100 for example, 4 minus 100 squared is clearly negative, and so this will not be in the domain. We also need to take out negative 2 and 2 because negative 2 would make the denominator 0, and 2 would make the denominator 0 as well. The function f of x is the combination of tangent x and 1 over the square root of 4 minus x squared. And so the domain of the function f is the intersection of all of these domains. And so the domain of tangent of x is all real number, except these are a few odd multiple of pi over 2. Negative 3 pi over 2, negative pi over 2, positive pi over 2, positive 3 pi over 2, positive 101 pi over 2, and so on. For 1 over the square root of 4 minus x squared, we write 1 over the square root of 4 minus x squared so that we can view the function f of x as the product of these two functions. The domain of 1 over the square root of 4 minus x squared is from negative 2 to positive 2, not including negative 2 and 2. The part that these two domains shares is negative 2 to negative pi over 2. Negative pi over 2 to pi over 2. And pi over 2 to 2. Thus, the domain of the function f is negative 2 to negative pi over 2, union with negative pi over 2 to pi over 2, union with pi over 2 to 2. The function f of x is continuous on this domain.